Okay, so here are our results tabulated. So we did 12 trials, 1 through 12. We counted the number of 1s, 2s, 3s, 4s, 5s, and 6s we got. And so and then these 10s out here, just making sure that we tallied 10 rolls every time. So tell me about the numbers you see before we tally the numbers up.
Well, it's interesting that every roll except for one, this 11th roll here, has at least 1 0.
Okay.
I think we've got roll number 4 actually has two zeros.
Interesting.
So I would have expected that we would have seen every number most of the time.
Okay. So we did find a lot of zeros.
Yep.
Okay. And that was a surprise. What's something you noticed about those numbers?
Well, sometimes when we had like a lot of one number, like when we had 4 of one number, then it was pretty likely that there would be a 0.
Yeah. Why is that?
Because like then 4 of the 10 dice are already being used for one number, so it's pretty unlikely that you could get one of every other numbers. So.
Okay.
And we also did not go higher than 4. We did not see any 5s or higher.
Didn't see any 5s.
We saw 4, 3, 2, 1, 0.
Okay. All right. Well, let's tally these up. I always forget how difficult it is to work through the computer here, but let's do some here. And how many? What were we expecting for an average number here?
Close to 20.
Close to 20. All right. So we got 14 1s, 26 6.
2s, 23. Like there are a couple. These ones were way off, but the rest were pretty close.
All right. So what do you think? What do you think about the dice here?
So, I mean, this isn't actually a lot of dice trials, but just from what we have here, the ones are low, like really low, and the 2s are pretty high.
Uh-huh.
But 3 through 6, I would take that as being okay.
Yeah, and if you actually evened out, if you took the extras from 26 and added them to the 14, you would get 20 and 20.
Oh, interesting. Okay, well, there's a couple of simple statistical tests we could do here. One's called the chi-squared test, and I can compare this to 20s, all 20s. Am I still on the screen here? Yep, I am. So, with the chi-squared test, it's going to return a number between 0 and 1, and you want it to be high. I think chi-test in Excel is the thing, so I go, what am I, B15. Sorry for reaching around the camera here to G15. And I compare that to B16 to G16. I think that gets it. Okay, and a low number, it's going to be a number between 0 and 1. A low number would mean not very good results in terms of the dice being pure random, and a high number, closer to 1, would mean good results. That one we're right at 50%. Interesting. All right. So, what does that tell us?
They're maybe like half random. Well, for this set of rolls.
Yeah, it tells us we don't know for sure right now.
And we also don't have any other reference points.
Yeah, we can't say for sure that these are purely random, but we also can't. It's not quite enough to say they're not. But maybe we need to do more trials.
Yeah. So the margin, like we did, these are pretty small numbers.
Uh-huh.
So maybe it's such that we only get, like maybe this is the margin gets smaller. Like if we had 100 rolls of each, and instead of 10, we did like 10 times this much, and then maybe reevaluated.
Yeah, and let's take your idea that if these evened out somehow, if this became a 20 and that became a 20, all of a sudden our chi-squared would be absolutely perfect. And
So
so
it's just those two columns.
14 and 26. So that kind of does show you that we haven't done enough trials yet.
Yeah.
That just kind of switching two of the columns or combining two of the columns. So we would need to
Yeah.
do a lot more. So, but an interesting results. Can you think of any other numbers we could test here to see about the randomness of the dice?
Well, you can see what they add, the sum. You can see what, like, for one set of rolling, you can see what they add to.
Okay. We could see.
You can go off the expected value there.
Yeah, we could look at the expected value of the sum.
Well, you could look at. I mean, there's not really enough numbers, but you could maybe look at like a normal distribution. Oh, there's only 6 numbers, so it might not make a lot of sense.
Yeah, well, it's an interesting instincts. It would the deviations around 20 should form a normal distribution.
Yeah.
That's right. Another thing we could do, going back to your zeros, we could focus on each one of our rolls, how many ones we got, how many zeros we got, how many twos we got, and that would be another test. So there's lots of different things we could do.
Yep.
Anyway, good work this morning, guys. High five.